boy, things sure have changed. Since then, the vehicles have become so much more advanced in their mechanical, electrical, and control systems. Of course, many of the vehicle changes in recent years have come about due to increased environmental concerns and stiffer emissions regulations. Take the Neon, for example. It contains one of the most advanced onboard emissions diagnostic systems of any vehicle on the road. This month on MasterTech, we're going to take a look at this new onboard diagnostic system, OBD2, as well as Chrysler Corporation's new diagnostic scan tool, the DRB III. OBD2 is a new onboard emissions diagnostic system required by government regulations. Chrysler has developed its own system to meet these regulations. Actually, there are several requirements that must be met before a vehicle will comply with OBD2 standards. First, a standardized data link connector is required. All automobile manufacturers, foreign and domestic, are required to use this 16-pin connector. In addition, on every vehicle, the connector must be located under the instrument panel near the steering column. Another OBD2 requirement is that a generic scan tool must be able to access any vehicle data relating to emissions. Still, the biggest changes required by OBD2 do not relate to access of information, but to the emissions information itself. While OBD1 tests measured an emission component's operation, OBD2 requires that the emissions system's performance be monitored. In other words, the new onboard diagnostic system must check not only that each component is functioning properly, but that each component is functioning properly with respect to the other components, which can affect the vehicle's emissions. OBD2 also requires that the driver be informed when an emissions-related component malfunctions or deteriorates to the extent that vehicle emissions exceed certain thresholds. This is accomplished by illumination of the malfunction indicator light on the instrument panel. In Chrysler's case, the check engine light is used as the malfunction indicator light. The mill must be illuminated no later than the second consecutive time that component or system malfunction occurs. And in the case of misfire, where catalyst damage is imminent, a flashing mill indicates to the driver that continued driving of the vehicle is not recommended. Of course, there are a large number of components responsible for controlling vehicle emissions. So, what has the responsibility of making sure the system is running smoothly? Well, that's the job of the powertrain control module. The PCM coordinates component operation and monitors system operation to keep the engine running in the most efficient manner possible. The PCM must monitor the following: catalyst efficiency system, fuel system, engine misfire detection, oxygen sensor and heater, EGR system, evaporative system, secondary air system, and any input or output components which can affect emissions. However, all of the systems may not be found on every vehicle. The Neon, for example, does not include a secondary air system. But when any of the systems are included on a vehicle, they must be monitored by the PCM. To give you a better idea of how the PCM monitors the system and coordinates component control, let's take a look at the catalyst efficiency system. Current vehicles use three-way catalytic converters. You may remember from the January 1993 program that these three-way converters reduce the amount of hydrocarbons, carbon monoxide, and nitrogen oxide in the exhaust. And an oxygen sensor is used to measure oxygen content of exhaust gas before it enters the converter. When the engine is running properly, this sensor should switch fairly rapidly. However, previously there was no way to measure the oxygen content of the gases after they passed through the catalytic converter. So, for OBD2 vehicles, a second oxygen sensor was added downstream of the catalytic converter. This downstream O2 sensor is used to detect the oxygen level in the exhaust after it passes through the catalytic converter. A properly functioning catalytic converter stores oxygen that is used for the oxidation of hydrocarbons and carbon monoxide. Therefore, the downstream sensor will switch at a significantly lower rate than the upstream sensor. As the catalytic converter deteriorates, both its oxygen storage capacity and its efficiency are reduced. When this happens, the switch rate of the downstream O2 sensor begins to approach the rate of the upstream O2 sensor. With OBD2, this system is monitored, so that if the switch rate of the downstream oxygen sensor reaches 90% of the switch rate of the upstream oxygen sensor for automatic transmission vehicles, or 70% for manual transmission vehicles, the mill is illuminated. Now, we said earlier that it was the job of the PCM to control and coordinate the monitors. This means, for our example, that the PCM must look at a variety of conditions before it goes ahead and checks the catalyst efficiency. First of all, there are certain conditions that must be met. For the catalyst efficiency monitor, these conditions, called enabling conditions, include specific values for engine coolant temperature, vehicle speed, engine RPM, and map voltage. And a vehicle must be at open throttle and in closed-loop operation. The monitor will be run once each key cycle if these conditions are met. However, the monitor will not run if the PCM recognizes the presence of certain conditions called pending or conflict conditions. These conditions may occur if, for example, the mill is illuminated for a certain diagnostic trouble code, or if another monitor is in progress. To get an idea of the pending and conflict conditions which may keep the catalyst efficiency monitor from running, and for a list of the specific values for the enabling conditions, see this month's reference book. In addition, the PCM will not record the results of the monitor until the oxygen sensor monitor passes. So, if the test has been performed and the downstream oxygen sensor reaches a high enough switch rate, the mill will be illuminated and the diagnostic trouble code stored. Of course, this is just one very simplified example of how the PCM prioritizes and controls the many systems and components affecting vehicle emissions. As you can see, the PCM has a big job in the smooth operation of the new OBD2 system. But now that you understand a little bit about what will happen with the new onboard diagnostic system, you may be asking yourself, so what will OBD2 mean to me? Well, really, it will mean a change in many of the diagnostic trouble codes. Several new codes have been added, and changes have been made to the set conditions of the present codes. You must also recognize the malfunction indicator light signals. Remember, a flashing mill indicates misfire situations, and that continued driving under these conditions could cause catalytic converter damage. If the mill is illuminated, use the scan tool to check for diagnostic trouble codes. And you must be sure to erase the codes after a repair. You should also be aware that the mill may be on a lot longer than it was in the past. This is because the mill is no longer extinguished after one key cycle. If, for example, the mill is on due to a comprehensive component such as a coolant temperature sensor open, the PCM must first recognize that the engine has been run for at least 2 minutes, then pass both the oxygen sensor and EGR monitors before it can verify that a previously malfunctioning component is meeting normal operating conditions. The PCM also requires that this occur 3 consecutive times before the mill is extinguished. Finally, you should be aware that in many states, before license plates can be issued, the vehicle must have run and passed all of the monitors at least once. Records of these passes are stored in the PCM, but be careful. Any time a vehicle's battery is disconnected, all records of passing monitors, as well as any diagnostic trouble codes, are erased. For the rest of this program, we're going to discuss the new scan tool, the DRB III. But before we move on, let's try this review question. The check engine light on an OBD2 vehicle has come on due to a problem with the engine coolant temperature sensor. For the light to go off, which of the following must occur? A, 1 key cycle. B, the PCM must find the component functioning properly only once. C, the oxygen sensor and EGR monitors must be run before the component can be tested by the PCM. The answer is C. The oxygen sensor and EGR monitors must be run before the component can be tested by the PCM. And the PCM must verify proper operation of the component 3 consecutive times before the mill is extinguished. By now, most of your dealerships have probably received the new DRB III. And many of you may be wondering, why the new scan tool? Well, just as OBD2 is the onboard diagnostic system of the future, the DRB III is the scan tool of the future, designed to work with Chrysler's first OBD2-ready vehicle, the Neon. So, throughout the rest of the program, we're going to talk about features, functions and maintenance, and diagnostic procedures for the new DRB III. But first, let's take a look at some of its highlights. The first thing you may notice when you pick up the DRB III is its size. It's quite a bit larger than the DRB II, not only in the body, but also in the display. And for good reason. The high-resolution screen of the DRB III can display 3 times the amount of text of the DRB II, saving you from switching back and forth between screens. In addition, backlight and screen contrast features can be used to improve the readability of the screen display. Oh, and one other little feature of the scan tool screen. It can display graphics such as bar graphs and engine analyzer scope traces. Not bad, huh? Well, there's more. Another great feature of the DRB III is that you no longer need application-specific cartridges for future standalone vehicle diagnostics. It has an updatable onboard memory to store diagnostic information. The DRB III can also be used as a true digital multimeter. You can use this scan tool to measure both AC and DC voltage, current, resistance, and even temperature. So now you know a few of the interesting features of the new scan tool. But what vehicles can you use it on? Of course, you already know that you can use the DRB III for Neon diagnostics, and it can be used for standalone diagnostics on all 1994 vehicles as well. The DRB III can also be used in conjunction with the MDS on any vehicle which the MDS is currently able to diagnose, provided Release 12 is installed on the MDS unit. In our next section, we'll go into the shop where Mike, our technician, will tell you more about the DRB III and its accessories. But before I turn it over to him, here's another review question. With the new DRB III, you can A, diagnose only the 1995 Neon, B, use the same super cartridge you used with the DRB II, or C, measure voltage, current, resistance, and temperature. The answer is C. The digital multimeter function of the DRB III allows you to measure voltage, current, resistance, and temperature.
After listening to Doug describe it, the DRB III sounds like a great new scan tool. Well, it is. You'll find many new features and accessories that were not available with the DRB II. In this section, we're going to take a look at some of these, starting with the keypad. One of the most obvious changes to the DRB III from the DRB II is the placement of the keys. Most of the keys, like the arrow keys, read, hold, and enter, have been moved to different locations on the DRB III keypad. However, unless otherwise indicated, their functions will remain the same as on the DRB II. Like the DRB II, the row of F keys is located across the top of the keypad, just below the DRB III display. However, the DRB III will provide on the display the function options available with the program in use. In addition to key placement, another change you'll notice in the keypad is that the number keys are now alphanumeric keys. Again, the number keys are used to enter data, but in the future, you'll be able to use the DRB III keys to enter letters as well. One key that is new to the DRB III is the More key. This is used to advance a numbered screen display to the next screen. For example, when the message Page 1 of 2 appears, it is the equivalent of the right arrow key. When using the DRB III with the MDS, pressing the page forward key will move you to the next screen. And of course, the page back key is used to return to the previous menu. But unlike page forward, the page back key will work with the MDS or with the DRB III in standalone mode. Next is the DVOM key. This has two important functions on the DRB III. First, pressing this button switches the DRB III to the multimeter function. Pressing it again allows you to leave. And to backlight the screen in low light conditions, press the DVOM key and the Yes key at the same time. The backlight function shuts off if the scan tool is not used for approximately 15 minutes, and it comes on with each power-up of the scan tool. However, backlighting should be used only when necessary. In order to extend the life of the backlighting panel, turn off the backlighting feature when not in use. Screen contrast is another feature of the DRB III. Enter the screen contrast feature by pressing the Yes and page forward keys at the same time. Then make adjustments by pressing the arrow keys. You should also be aware that temperature will affect screen contrast. Low temperatures will cause the screen to lighten, and high temperatures will cause the screen to darken. This is important information in the event your DRB III screen is unreadable. As long as the red or green LED light is on when you power up the DRB III, your scan tool is operating properly, but may need screen contrast adjustment. Of course, improvements to the new scan tool don't end with the keypad. In order to prevent obsolescence of the base unit, engineers have designed the DRB III with a removable module. It's referred to as the Peripheral Expansion Port, or PEP module. By replacing this module, you can add to the capabilities of the hardware and software of the DRB III without having to change the base unit. Upgrades can also be performed via a memory card. This card, which is easily inserted into the handle of the DRB III, will be used for software updates to the DRB III, updates to the vehicle controllers, and additional memory storage as well. Be careful to insert the memory card with the correct side up, and not to force it in upside down. At the other end of the DRB III is the cable connector panel. Here you'll find ports which can accommodate two sets of test leads. Another port, labeled RS-232, allows for connection to a PC or a printer. At this point in time, the software is not available for outside applications, so a cable for this purpose is not included in your kit. Also on the connector panel are the ports for the 26-way MDS General Purpose Interface bus cable and a 36-way vehicle interface port to attach the vehicle diagnostic cable. Note that this vehicle port is not the same as the one on the DRB II and requires the use of cables designed especially for the DRB III. DRB II and DRB III cables are not interchangeable. However, your DRB III kit should include all the cables you'll need to run the DRB III for standalone diagnostics and with the MDS. Like the DRB II, you'll need to use different cables with different vehicles. Let's take a quick look at these, beginning with the 3 cables for use on vehicles without OBD2. Actually, these cables should already be somewhat familiar to you. The body cable, the engine cable, and the MMC cable look the same as the DRB II cables, except for the 36-way DRB III connector. 2 more vehicle diagnostic cables are included in the DRB III kit for use with vehicles that are OBD2 capable. You'll recognize these by this 16-way OBD2 connector. One cable is used for Chrysler domestic vehicles that have OBD2, like the Neon. The other will be used for Chrysler MMC vehicles equipped with OBD2 diagnostics. And each cable is coded, so the DRB III can identify it. Also included in your kit is a round 8-way DIN cable, which is used to power the DRB III from the MDS. This cable can also be used to attach your DRB III to the vehicle controller flash kit, when updating the vehicle controllers of older vehicles. The last cable included in your kit is the GPIB, or General Purpose Interface Bus Cable, which we mentioned earlier. This is the cable that will connect the DRB III to the MDS. However, it will not supply power to the scan tool and must be used in conjunction with a DIN cable or one of the vehicle diagnostic cables. Besides the cables, your DRB III kit contains several other accessories, including 2 sets of multimeter probes, alligator clips, a temperature probe, a low current shunt, and a high current clamp. You already know that with the DRB III, you can measure both AC and DC voltage, current, resistance, and temperature. But what you may not know is that with the DRB III, you have the option of using a single test lead, like with the DRB II, dual test leads, like a standard digital multimeter, or you can use 2 sets of test leads for simultaneous measurements. You should also be aware that shrouded multimeter leads must always be used with the DRB III. The shrouded leads not only help to prevent electrical shock, but are also used to inform the DRB III that the connectors are in place. Resistance measurements with the new scan tool are taken by inserting the test object between the 2 leads. Also, when measuring resistance, be sure the object being tested is not connected to voltage. Another accessory included in your kit is the temperature probe. This can be used to measure air or liquid temperature or the temperature of a surface. Current can be measured with either the low current shunt or high current clamp. When measuring current, be sure to use one of these tools. Do not try to measure current with the test leads connected directly to the DRB III. When using the low current shunt, the black test lead goes to the negative or common port, and the red test lead goes to either the 2 amp or 10 amp plug, depending on your knowledge of expected current flowing through the device. If in doubt, try the 10 amp connector first. Also, each of the test scales, 0 to 2 amp and 0 to 10 amp, is fused separately with automotive fuses located on the back of the shunt. The high current clamp is used to measure alternating or direct current up to 2,000 amps. Current measurements using this device are obtained by placing the jaws of the clamp over the wire to be measured and selecting the appropriate range, 0 to 200 amps or 0 to 2,000 amps. A dial on the front of the clamp may be used as a zero adjust knob if necessary, and power for the clamp is provided by a 9-volt battery, which should be removed if the clamp is not used more than once a month. Finally, you should be aware that when the current is below 10 amps, readings made with the clamp may not give you the accuracy you desire. Therefore, it is recommended that for more accurate current readings in the 0 to 10 amp range, you use the low current shunt and use the clamp for readings above 10 amps. Earlier in the program, Doug mentioned that, like the DRB II, the DRB III can be used in conjunction with the MDS. It can also be used as the MDS data recorder. However, the DRB III will only operate with the MDS if release 12 or later of the MDS software is installed on the unit. And besides its diagnostic uses, the MDS also acts as the main means for updating DRB III or vehicle controller software. Through the use of the telephone interface, floppy disk, or CD-ROM, the MDS can receive and hold program information for downloading to the DRB III. In addition, the DRB III will allow for development of more comprehensive and varied diagnostics for the MDS. And the DRB III will allow improvements to the speed of MDS diagnostics. Finally, the DRB III is hooked up to the MDS with a GPIB cable. This cable is different than the DRB II cable, and it must be installed on your unit before the DRB III and MDS are compatible. Some of your MDS units may already have this cable installed, but if not, don't worry, it's simple. In the next section, we'll show you how to install this cable and a couple of maintenance procedures for your DRB III. But first, let's try another review question. Which of the following is not a means for updating the DRB III software? A, the MDS, B, a memory card, or C, a personal computer? The answer is C, a personal computer. The DRB III can be updated by the MDS, a memory card, or the PEP module. So now you know there are a couple of things you need in order to use your DRB III with the MDS. Release 12 or a later release of the MDS software. And of course, the General Purpose Interface Bus or GPIB cable. These can be installed on the MDS in any order, but should be done as soon as possible. Let's take a quick look at how to properly install this cable. Your first step is to power the MDS down using the white power switch on the front of the MDS. Next, with the MDS in a location where you have clear access to the back panel, loosen the 4 attaching screws. Be sure to use the handle cutout to prevent the back panel from falling while you loosen the screws. Next, remove the back panel and locate the GPIB board connector in slot 3. If slot 3 is empty, your unit has not yet been updated with the GPIB board, and you should contact the MDS hotline for assistance. If your unit has been updated, you're now going to install the cable. Start at the left-hand cable relief strap and route the cable behind the existing cables and around the right lower back panel standoff. There are 2 things to remember here. 1, it is important to use the left-hand cable relief strap to prevent possible damage to the MDS, the GPIB board, or the cables. And 2, do not route the cable through the same restraint as a cable of a much larger diameter. This will not secure the cable properly and would defeat the purpose of the strain relief. But what about the DRB II cable? Is it okay to leave it routed through the left-hand strain relief strap? It sure is. In fact, both the DRB II and GPIB cables should be installed under the left-hand strain relief strap. So once the cable is routed properly, your next step is to attach the cable connector to the GPIB board and hand tighten the attachment screws. Then hand tighten the relief strap screws. Install the back panel and you're all set. The maintenance procedures used with the DRB III are even easier. One procedure allows for replacement of a cracked or damaged lens on your DRB III. If damage to the lens should occur, you'll first need to order a lens replacement kit. This kit is available through OTC by calling 1-800-533-0492. Actually, there are 2 lens replacement kits available. One containing a standard lens. The other contains a non-glare lens, which you may want to consider if your DRB III is frequently used in brightly lit areas. So, once you have the new lens, simply peel off the display face decal on the DRB III and remove the old lens. Clean the surface to which the new decal will be applied using a standard glass cleaner. Also clean the DRB III display face and the new lens if necessary, and seat the new lens. Finally, place the new decal on the cleaned surface, and your DRB III is as good as new. And to keep your DRB III as good as new, there's one more maintenance item you should be aware of. As you may know if you've used the DRB III, there's a cooling fan on the unit that should run continuously when it's powered up. It's important not to block this fan, because insufficient airflow may cause the DRB III to overheat. It's also important to periodically snap the fan cover off and check the air filter. If the air filter appears to be dirty, it should be replaced. A replacement filter kit, also available through OTC, contains 5 new filters and a filter cover. In our next section, we're going to discuss a couple of differences between the DRB II and DRB III diagnostic procedures. But first, try this review question. Which of the following statements is true about the GPIB cable? A, it should be routed through the right-hand cable relief strap. B, it can be retained in the same relief strap as the DRB II cable. Or C, it can be used to hook up the MDS to both the DRB II and the DRB III. The answer is B. The GPIB cable and DRB II cable should both be routed through the left-hand cable relief strap. Now that you know why the DRB III was introduced and some of its unique features, your next step is to use it in diagnosis. Currently, the diagnostic procedures used with the DRB III are very similar to those on the DRB II. But before we conclude for this month, there are a couple of items related to DRB III diagnostic procedures that you should be aware of before you power up your new scan tool. First, you'll notice that the DRB III main menu is much different than the DRB II. With the DRB III main menu, you have 6 options. The standalone DRB III option allows for portable handheld use of the DRB III. To use the DRB III in conjunction with the MDS, or as a data recorder, you would choose MDS Diagnostics or one of the data recorder options. The Run Memory Card option is used for DRB III software updates by way of the memory card. And Self-Test includes several DRB III self-test options, including an interactive keypad test and a display test. This is also where you can find the software version and cable ID number. Now, earlier in the program, Doug mentioned that there is another important difference between DRB II and DRB III, which directly relates to diagnostic procedures. Do you remember what it was? It's the onboard memory of the DRB III, which stores standalone diagnostics, eliminating the need for application-specific cartridges. From this information, you may expect access to system options to be difficult and include several menus, but this is not the case at all. In fact, once you've chosen the standalone DRB III menu, you simply choose between Chrysler Domestic and Chrysler Mitsubishi vehicles, and then select your system. And one more important change in the DRB III, which you should be aware of, concerns the digital volt-o-meter function. Similar to the DRB II, the digital multimeter function can be obtained at any time during your diagnostic procedure by pressing the DVOM key. But unlike the DRB II, the DRB III has the ability to take 2 multimeter readings and display them on screen simultaneously. When both channels are selected from the digital multimeter menu and connected to leads, the 2 readouts will appear at the bottom of the screen. This will allow you to read, for example, voltage with one channel while taking a temperature measurement with the other. Well, that's it for another MasterTech. This month, we've discussed some of the changes you'll see with the introduction of OBD2, and we've shown you some of the highlights of the newest member of Chrysler's diagnostic team, the DRB III Scan Tool. Next month, we'll see the DRB III in action when we discuss the Neon anti-lock brake system. If you'd like to learn more about OBD2 or DRB III, training classes and further DRB III operating instructions are available through your local Chrysler Training Center. We'll see you next month on MasterTech.